Thank you for supporting CMA Math Academy. If you're watching on YouTube, don't forget to like, comment, and subscribe for more great CMA math content. What's up, guys? Obviously, I'm not here today. The sub is here, and you're going to dominate. You're going to do a great job while the sub is here. So we're going to go through this video. In the video, you're going to be taking some notes over elimination. So here's how this is going to work. You have your foldable that we did substitution stuff on. So you have your foldable that we did substitution information on already. Okay, we already did this with substitution. You're going to flip that over, and you'll have your elimination information on this same foldable. So on one side is going to say substitution, and on the other side you're going to have all your information for elimination on the same foldable. Now, if you were not super responsible and you have lost yours, you've misplaced it, you're going to raise your hand. Don't blurt it out. Just raise your hand, and the sub is going to give you another piece of paper that you can use. But for those of you who did what you were supposed to and you kept your other foldable, this is going to go on the back of that foldable. So it's already going to be folded into fourths, and we should just be ready to go. Remember, we treat the sub with more respect than you treat me. I expect there not to be any issues. You guys are great. Have a great day. What's up, guys? Let's talk about what we're going to learn today, why we're learning this, and how you'll know if you've successfully learned it. So today, you guys will be able to solve a system of equations using the elimination method. Everybody say elimination. So we've talked about graphing and substitution. So why are we doing this today is because we've already learned those two ways. We need to look at the third way, which again is elimination, and the final way that we're going to solve for systems of equations. Let's look at our last thing. So how will you know if you successfully learned what you needed to learn today? So at the end, when you're given a system of equations, if you can use elimination to determine the solution, then you're successful. So again, like the past couple weeks here, you're going to get your notes, you're going to get your information today, then we'll spend a couple days practicing before our quiz. Just heads up, most of the time in the past experience that me and Mr. Strog have had, when we get to elimination, a lot of the times the kids are like, well, why didn't we just learn this way? It's easiest. But you have to know the other two ways to really implement elimination. So hopefully today, like a light bulb will come on, and you'll be like, man, elimination is easy and simple. We should have done this the whole time, and you'll get what we're talking about. So on your first slide here, we have steps to solve using elimination, and I want you to write this in your top left box. So I'm going to give you a second to jot this down in the top left box of your foldable. All right, so now that you've had a chance to write, let's go ahead and read through these. Again, when I stop, you get the next word that I leave off on. So it says, well, number one, the first thing you're going to do is look to see if any of the have the same, and then in our asterisks here it says if none are the same, you're going to. Okay, so we'll break down what that's saying here in a minute when we go through some examples. Let's look at question number 2. If we have the same signs, then we're going to, and if we have different signs, then we're going to. Okay, and number 3 looks pretty familiar, hopefully from substitution, so you're going to help me out on 3 by saying this word. Ready? 1, 2, 3. So far we got our first solving like substitution was. So number 4, you're going to substitute your back into the easier. So again, this is a step from substitution. This part is. And then again, number 5, we're going to say this word on 3. Ready? 1, 2, 3. And then lastly, number 6 says write your 2 answers as an ordered. All right, so we have about 6 steps. And really, 3, 4, 5, 6 are the same as what we have for substitution, but you'll really appreciate the top 2 steps are going to be a little bit more concise and simple compared to what we had with substitution. Okay, so let's go ahead and get started. Let's look at some examples. So in your top right box, I'm going to give you a second to write down. This is an example when you already have the same coefficient. So I'm going to give you a second, write same coefficient, get this example written down, give you a second for that. All right, so see what we got here. So in our first equation, we have negative 4x minus 2y equals negative 12. Our second equation says 4x plus 8y equals negative 24. So it says up at the top, same coefficient. Now some of you might be like, well, Mr. Graddy, we know that negative 4 and 4, those aren't the exact same. When we're looking at elimination, all I'm looking at is the number, not the sign. So even though this says negative, we're only looking at the 4x and 4x, and that gives us the same coefficient. So that was step number 1, that we had the same coefficient. Step number 2 told us that if we have the same signs, now we look at the signs, we're going to subtract. If we have different signs, we're going to add. So let's look at this. I have -4 and +4. So you tell me real fast, is -4 and +4, are those the same signs or different signs? Okay, well hopefully we know this. -4 and +4 are different. So this tells me that I'm going to be adding. Now here's what I mean by adding. So you're going to make this whole situation, this whole system, into one giant addition problem. So we're going to draw a line underneath. Then we're going to split our equation down the equal signs. Okay? And then like I said, this is going to become an addition problem, so we're going to put a plus sign over here to the left. So this just became one big addition problem. So what we're going to do is we're going to add just like we would normally. So we're going to start on the left, and we're going to add going across. And here's what I mean. So you're going to add whatever's in the top equation to whatever's in the second equation. So we're adding -4 plus +4. So let's think about that. If I'm adding a positive and a negative, I really subtract them. So you guys help me. What's 4 minus 4? Okay, and we know 4 minus 4 is 0, so those cancel each other out. So what that tells me is there's no more x's right now. Okay, so my x's have been eliminated. That's why this is called elimination. Let's go to the second part. My y's say -2 plus +8. So let's do that. Again, if I'm adding a positive and a negative, I really subtract them. So you're telling me what is, so everybody help me here, what's 8 minus 2? So we should have had 6y. So we're going to write 6y down below. Then we're going to bring our equal sign down. Then we're going to move to the right side and do the same thing. So I have -12 plus -24. So when I add negatives, I keep my negative sign and I get a bigger negative. So really what you're trying to tell me is what's 12 plus 24. So everybody help me out. What is 12 plus 24? Okay, we should have said 36, and we already knew it was going to be negative because they're both negative. So now we have a really simple equation we can solve. We have 6y equals -36. So I'm going to give you a second. I want you to tell me what y equals. So solve this out. All right, so let's check our work. Make sure we do this correctly. So we have 6y on the left side, so we need to divide both sides by 6 to eliminate or cancel out our 6. So I end up with y equals, and everybody help me out, you're going to tell me the answer on 3. Remember, a negative divided by a positive gives me a negative, so you're going to tell me the answer on 3. Ready? 1, 2, 3. All right, so we ended up with -6 for our y value. Okay, so those were just the steps that were kind of new. From here, it's just like substitution. So if you think back to substitution, once you have your first answer, you're going to substitute that into the easier equation. So let's examine our two equations real quick. Up top, we have -4x minus 2y equals -12, and we have positive 4x plus 8y equals -24. Now when you do the substitution, even though we eliminated our x's to start with, they come back into play. So we still have these x's to use. Okay? So if we look, we have an equation that has several negatives here at the top, or at least we have some positives on the second equation. So we're going to take -6, and we're going to sub it into our second equation. So this is just like what we've been doing with substitution. So we're going to take that equation, we're going to rewrite it out to the side. So I have 4x plus 8, but remember from substitution, we know that instead of y, in parentheses, we're going to write what y is worth. So we already saw this. Everybody help me out. Remind me, what was y? So we're going to put -6 in our parentheses. And then we have equals -24. I'm going to give you a second. You tell me what x equals. Go. Okay, so let's see how we did. So on our left side, we want to go ahead and multiply 8 times -6. So you guys help me. Positive 8 times -6 gives me, and we should have said -48. Okay, and I'm just going to drop down my 4x. So I have 4x minus 48 equals -24. And then I need to move my -48 to the other side. Again, help me out. What's the inverse of subtraction? So everybody, what's the inverse of subtraction? Okay, so we should have said addition. So we're going to add 48 over to this side. And that leaves me with 4x equals negative 24 plus 48. Remember, adding a positive and a negative, we really subtract them. So this leaves me with positive 24, and I just have to divide my sides by 4. So on 3, you're going to tell me what our answer is. Ready? 1, 2, 3. And we should have said positive 6. So as always, our very last step is to write our answer as an ordered pair. Remember, our x's come first, then our y's. So our answer should say 6, negative 6. And as we've talked about before, if I can get an ordered pair, that's going to give me one solution. Here's my final answer. Okay? So this was our top right box. Let's go ahead and look at our bottom left box. All right, so let's look through this and get this solved. So remember, our first step is that we need to check to see if there's any coefficients that are the same. So for x's, we have 5 and 10. We know those aren't the same. Remember, if we have a variable by itself, there's really this 1 here that we can't see, but that's 1 and negative 7, and we know those aren't the same either. So for us, no coefficients are the same. So if you look at your steps, we put little stars around it, and it said that if none of them are the same, then we're going to have to do some multiplication. So here's what I mean. If we look at our equations, I want you to think about this. Could I multiply 5 by anything to make it a 10? So help me out, everybody. What can I multiply 5 by to make it 10? So I could multiply 5 by 2. Let's look at y. Y is a 1. Could I multiply 1 by something to make it a negative 7? So again, I could multiply 1 by negative 7. Now we can't do both, we have to choose. So I could either choose to multiply everything by 2 or multiply everything by negative 7. So for me, I think positive 2 is a little bit easier to multiply. So here's what we're going to do. We're going to take, kind of like the distributive property here, and we're going to multiply this entire top equation, every single number, by 2. Okay? Now when we do this, we're going to write our answer down below. So there's going to be a little bit of organization to this. You got to make sure we follow along. So we're going to distribute 2 times 5x, and that's going to give us 10x. So as you see, I'm writing this down below. Plus, what's 2 times 1y, everybody? So that's plus 2y. And then finally, 2 times 9. Everybody, what's 2 times 9? So now I have 18. Okay? Now, order for systems of equations, especially with elimination, is very important. So we can't just work it like this. The next step we have to do is take this equation and write it down below, our second equation. So we're just lining things up. So we have 10x now minus 7y, and that's going to equal negative 18. All right, so basically what we've done is we've said these two equations, we're done with those, and we're only going to look at these two now. We've basically redone our problem to make it have something that's the same. So now we go back to that first step and we say, okay, which coefficient is the same? And now we can see we have 10x and 10x. So let's look at step 2. Remember, step 2 was if they're the same sign, we're going to subtract, and if they're different signs, we're going to add. Well, we have positive 10 and positive 10. Those are the same sign. So we're going to draw a line below. We're going to split our equal sign, and we're going to turn this into one big subtraction problem. So there's our minus sign. We're going to subtract these out. Okay? So just like last time when we did addition, we're doing it with subtraction. We're going through every step. So we have 10, positive 10, minus positive 10. So you guys tell me, what's 10 minus 10? Okay, so we know that's 0. So that's going to cancel out our 10s. Okay, let's go to the next one. Positive 2 minus a negative 7. So we had some problems like this last week with our substitution. If I have minus and a negative, remember that really turns it into addition. So it's really 2 plus 7. So help me out. What's 2 plus 7? And that's going to give me 9y. So it's really important. We got to be careful with our signs. Okay, let's look at our last one. We have 18 minus negative 18. So same thing here. 18 minus a negative turns it into adding. So if we have minus a negative, that's adding. So we're really doing 18 plus 18. You guys help me out. What's 18 plus 18? should give us 36. So I'm going to give you a second. I want you to divide this and get your answer for y. All right, so let's see how we did here. So we should have divided both sides by 9. Okay. And on 3, you're going to tell me what y equals. So y equals, everybody, 1, 2, 3. We should have said positive 4. Okay, so now it's just like substitution. The cool thing is now we have really 4 equations to choose from. So we have our 2 equations up here that we kind of scratched out, and we have our 2 new equations, and we just have to pick whichever equation we want to put 4 in for y. So as I'm looking through mine, I probably want to avoid this second equation because it's got a negative, and here's a negative y, 7y. So I would either pick the 10x plus 2y equals 18, or the original 5x plus y equals 9. So for me, I'm going to draw my arrow all the way up to my first equation, and I'm going to use 5x plus y equals 9. So again, we're going to take that, write it over to the side, and we have 5x plus, but instead of y, remind me one more time, what's y, everybody? Okay, and y is 4, and that's going to equal 9 for us. So I'm going to give you a second here. I want you to solve for x. Ready? Go. Okay, so let's check how we did. So remember, we want x by itself. So we're going to save this 5 coefficient for last, and we needed to move our positive 4. So just remind me real fast, what's the inverse of adding 4? So we got to subtract 4 to our other side in order to cancel these out. So 9 minus 4 gives me 5, and I have 5x equals 5. And then our last step should have been division. And one more time, you guys are going to tell me what our answer is. So on 3, you're going to tell me what 5 divided by 5 is. Ready? 1, 2, 3. And x should have been 1. So as always, we need an ordered pair with x and y. So our x value was 1, our y value is 4, and you guys help me out. How many solutions is this going to be? We should have 1 solution. So there's our final answer. Very good. All right. So let's look at our very last box. We're going to the bottom right box now. Now, if we think about the past 2 examples that we've done, the first equations that we did in our top right box, they already had values of x that were the same. So we just could go ahead and turn that into addition or subtraction. In our second example, the one in the bottom left box, we had to multiply one equation to make it equivalent or equal valued to the other equation. So let's look at this equation. If I think about this, can I multiply 5 by anything to make it a 3? Well, I can't. And I can't multiply 3 by anything to make it a 5. If I move over to the y's, I don't want to multiply 4 by something to get negative 9, and I can't multiply negative 9 by something to make it a 4. So that tells me I might have to multiply both of the equations in this instance. When you're doing this, think of it as like a common denominator with fractions. So when I'm adding or subtracting fractions, I have to find a common denominator. So a lot of times I just multiply by the other denominator. Same principle is going to work here. So if we think about this, you can choose whether you want to multiply to get your y's to be the same or for your x's to be the same. Now here's how you can kind of check. If I multiplied 5 times 3, so everybody help me out. What's 5 times 3? So that would turn into 15. So my x's would turn to 15. Okay, remember that number, 15x. Let's move over to the y's. Help me out again. What's 4 times negative 9? So that would give me negative 36. So if I multiplied the x's, they'd turn into 15s. If I multiplied my y's, they'd turn into negative 36s. Well, I don't know about you, but I'd much rather work with positive 15 than negative 36. So that tells me I'm going to multiply both equations to get my x's the same. So here's what I mean by that. So since our first equation is positive 5x, we're going to take our second equation and we're going to multiply that by 5. Again, we're getting that number from right here. Then we're going to do the opposite for our top equation. So our top equation is going to get multiplied by 3, and this is just to get our x's the same. So we're basically just distributing 3 out to the top equation and 5 out to our second equation. So let's do the top one together. So help me out. What's 3 times 5x? So that should be 15x, and we're writing this down below to give us some space. Plus, what's 3 times 4y? And that becomes positive 12y. Equals, what's 3 times negative 30? and that should be negative 90. Okay, so I'm going to give you a second. I want you to multiply out our second equation. You're going to write it down below. Go. All right, so let's see what we did on the second equation. So again, you're going to help me out. 5 times 3x gives me, we should have had 15x. 5 times negative 9 gives me negative 45y. And again, I need your help. Okay, so help me out. 5 times negative 18 gives me, and that should give me negative 90 as well. Okay, so let's look at this. So if we go back to our original steps, if the coefficients are the same, which we now have here with the x's, we either turn it into addition or subtraction. So remember, if they're the same sign, so we have 15 and 15, if they're the same sign, we're going to turn this into a big subtraction problem. So I'm going to draw my line, and I'm going to split my equation, and I'm going to make my subtraction sign over to the side. So this became a big subtraction problem. So then from here, we're just going to go ahead and subtract. So you guys are going to help me out as we go through this. So I have 15 minus 15. What's 15 minus 15? Now remember, since it's 0x, we don't write 0x down below. What that tells me is that my x's have canceled each other out, or they've been eliminated, since we're talking about elimination. Okay, let's look at the next part. It says positive 12 minus negative 45. Remember, we had one like this earlier. If it's minus a negative, you really change that to addition. So this is really 12 plus 45. Okay, so I'm going to give you a second to help me out here. So get that figured out, what 12 plus 45 is. Okay, on 3, you're going to tell me what 12 plus 45 is. Ready? 1, 2, 3. And that should have been positive 57. And we want to keep our y. Then finally, we have negative 90 minus negative 90. Again, same thing. If I have subtraction followed by a negative, that turns into addition. So it's really negative 90 plus 90. So if I'm at negative 90 and I'm going to add 90, that's going to end up at 0. Those are going to zero out. So I have 0 over here on the right side. So that tells me from here that I'm going to divide everything by 57. So we should have done that next. Divide everything by 57. And we had one like this the other day. We know we can't split 0 into 57 parts. So on 3, you're going to tell me what y equals. Ready? 1, 2, 3. And y should give us 0. So from here, we're going to substitute our y value back into one of the equations. Now remember, we really have 4 options. We have option number 1, option number 2, option number 3, and option number 4. Now if we just look at these 4 equations, these bottom 2 that we did, since we multiplied out, these are pretty big values. So I would stick to one of our top values up here. Now remember, we know that y is going to be 0. So it really doesn't matter which equation I put it in for, but I can tell that if y is 0, that 3x is going to be a little bit smaller, so I might go with that one. So we're going to take our y equals 0, and we're going to draw an arrow up to the second equation at the top. That looks like that. Okay? And like what we normally do, we're going to draw another arrow out, and we're going to have our work over to the side. So we have 3x minus 9. But we know that instead of y, we're going to put 0. We're going to substitute 0 in, and that's going to give us negative 18. So I want to give you just a moment here, and I want you to go ahead and get what x is. Okay, ready, go. All right, so let's see how we did. So everybody helping me out? What's negative 9 times 0? So I have 3x, and since it's 0, we don't need to write it. So 3x equals negative 18. My last step should have been to divide by 3. So on 3, everyone's going to tell me what x equals. Don't forget your negative sign here. Ready? 1, 2, 3. And our answer should be negative 6. Okay? So then we have our ordered pair to write. Remember, it's x first, then y. So I know it's going to end up as negative 6 and 0. And that's going to give me a 1 solution answer. Okay, so now that we've learned what to do in 3 different situations with elimination, we also know our steps. We're going to do some individual practice here. If you get stuck, table partners are available, or you can ask me for help. All right, great job today, guys.